SprintCalc 4 is a comprehensive calculation package for fire suppression systems. The base system is designed to perform hydraulic calculations. The program can also be authorized to perform fluid delivery time calculations for dry and pre-action systems. This is the FDT option, which is listed with Underwriters Laboratories. Through SprintCalc's many tools, the fire suppression system is assembled with discharging devices, pipes, fittings, and valves. The graphics area displays the 3D model. Right-clicking on nodes and pipes reveals their name and properties. Node information appears on the right, and pipe information is listed below. Automatic building tools include the overhead, in-rack, standpipe, and feed generators. These commands allow you to quickly build your system through a dialog box format. Heads, pipes, and fittings will be inserted in the correct position in 3D space with a few simple keystrokes. There are also a number of semi-automatic tools for placing nodes and pipes into your project. With the Add Nodes and Add Pipes tools, you can add single or multiple nodes or pipes to your job. The program also provides a number of tools for editing and modifying a project. New projects can be imported directly from SprintCAD 3D. The transfer includes the system geometry, as well as pipe, valve, and fitting criteria. This starting project model becomes the initial system. The model is made up of pipes and nodes. The nodes can be of varying types, including sprinklers, water supplies, hoses, and simple pipe connection points. In the initial system, the fittings are placed in the nodes by the layout utilities. You also have the opportunity to manually add fittings to the pipes in this environment. The pipes are used to connect the nodes and have several properties including size, material, and length, and whether they are wet or dry. Pipes may also take on the property of a valve and become backflow preventers, dry pipe valves, or other valve types. They could also be pumps. The preparations for a hydraulic calculation start with the creation of the initial system. All nodes, pipes, discharging devices, and fittings which will carry water in any design area must be in place. There must be at least one supply node with water supply criteria defined. When this is done, a design area is created, which identifies the active heads and sets the required density. When generated, the design area appears as a tab below the initial system on the left side of the screen. The design area environment eliminates any excess pipes or nodes that have no effect on the calculation. The graphic is simplified to include only those pipes that have flowing liquids in them. Several design areas may be established from the initial system if required. If any physical changes are made to the system, such as pipe sizes, K-factors, moving pipes or nodes, etc., they must be done within the initial system. The program will not allow you to make structural changes to the design area nodes or piping, since this may affect other design areas and resulting calculations. The Properties dialog box can be used to edit system elements. For example, here a pipe can be changed into a pump. Criteria for the pump are readily acquired from the database. When changes are made to the initial system, you will be notified that the existing design area results will be erased. They're easily re-established again with a calculation. The hydraulic model can be Hazen-Williams or the fully functional Darcy-Weisbach formula. Select one with the radio button. The calculation results can be scrutinized with the hydroanalysis screen. A summary of the results appears in the top row. The curve area allows you to select from a variety of options to customize the graphic. When returning to the project, nodes, pipes, and other objects can be observed through the Properties dialog box. In the design area environment, data includes the results of the hydraulic calculation. For example, here, a head has been selected. The Properties dialog box displays the pressure and discharge. A selected pipe displays the flow, velocity, and friction loss. Printed reports are quickly customized and generated with the Print Settings dialog box. The preparation for a fluid delivery time calculation also starts with the creation of the initial system. All nodes, pipes, and heads representing the entire system volume must be in place. There must be one supply node with water supply criteria defined and a dry pipe valve. When this is done, a headset must be created. Select the open heads from the initial system and create the headset. Select the design criteria from the dialog box to automatically retrieve the required delivery time and required number of heads. Calculate and press Summary to observe the results. The dialog box provides the dry pipe valve trip time and pump activation time if present. The fluid delivery time and operating time are listed for the most demanding sprinkler. The sprinklers of the headset are listed below with the calculation results. The analysis window displays accurate pressure and flow curves for selected devices over the calculated time. Here's one of the open sprinklers. At zero time, the heads open, allowing gas to escape to atmosphere. The gas pressure drops until the dry pipe valve opens at point 1. Water rushes through the system and initially flows out of the head at point 2. The pressure and flow spike at this point due to the momentum of the water. The water stabilizes at a lower flow rate in Area 3, since the system is being supported by the water supply only and the pump has not yet started. After a time delay, the pump starts at point 4. The pressure and flow spike again at point 5 due to the increased flow and pressure generated by the pump. The sprinkler operating pressure and flow oscillate in Area 6 and eventually stabilize. The headset appears as a tab below the initial system. Several headsets may be established from the initial system if required. Nodes and pipe data can be observed through the Properties dialog box. This head shows the fluid delivery and operating time. The fill-up routine precisely displays the flowing liquid in the pipes as the gas is expelled. As fluid reaches each open head, the fluid delivery times are displayed. The time analysis report provides detailed information on dry pipe valve activation and water delivery to heads. Graphs may be included for individual items such as heads, dry pipe valves, and pumps.